Submit. Bro. Alright, hello. I have a setup. Let's go. I'm also wearing a mask for uh you know what I mean. God, I'm forgetting all the words. Just in case, there it is. We're gonna do some physics. I forgot everything I learned. So yeah. It is different. I have a lot of notes. I forgot all of them in 6 months. These notes, they're all wasted. All the knowledge here gone. Not in my brain anymore. There it is. This is where I left off. We're gonna go to Khan Academy. The good thing is this notebook makes me look smart when I don't know any of them. Yeah, I have a display capture. How do you do this? Wait. There it is. Uh, do we just put it here? I mean, it looks chill, right? If it's bruh. That looks weird. I guess we could just do this. Yeah, boy. Alright, we'll start with this one. High school physics. Girl. Alright. What do your this how it works? Oh, I press learn. No. I am 18 years old. Hold on.
Newton's first law tells us that an object at rest will stay at rest, and an object with a constant velocity will keep having that constant velocity unless it's affected by some type of net
Alright.
force. Or you actually could say an object with constant.
I
Does
don't
a
think I
net
remember
force
doing this one
affect the
at
constant
all.
velocity or law of motion? And this one is maybe the most famous. They're all kind of famous. Actually, I won't pick favorites here. But this one
I
gives us
am
the
going.
famous formula: force is
I'm
equal to
not going to a
mass
university yet.
times
I'm
acceleration.
still a grade 12 student.
Acceleration is a vector quantity, and
All the way
force
here in
is a
Philippines.
vector quantity. And what it tells us, because we're saying, okay, if you apply force, it might change that constant velocity. But how does it change that constant
Welcome to
velocity?
my stream.
Well, say I have a brick
This is the
right
first
here,
time I'm
and
using
it is
a
floating in space.
camera for
Newton's
my
second
notebook.
law tells us, and it's pretty nice for us, that the laws of the universe, or at least in the classical sense, before Einstein showed up, the laws in the universe actually dealt with pretty simple mathematics. What it
Mm. Hold on, let me actually search what we're gonna. Cause I need to do this for an assignment, and like I've learned this last year, but I completely forgot. I learned this like for just myself. Also learned this because that would be interesting because I'm making a game and stuff. That'd be interesting. Burger. Hold on. Let me bring up something. Oh crap. Alright, here it is. This is what we need to learn. Apparently. Doing oh yeah, right. So this is like very basic physics because this is the only thing I learned last year. What? Why can't I type? What? Uh, God, just making you know. What is happening? Damn it. Yeah. Okay. So I've already got those stuff. I don't know if can you guys read it? Is it too blurry? What Among Us? Can you guys read it? Read the stuff. Hello. All right. Good. This is the stuff I know. Over here. I'm gonna put everything in red ink because that's how I do it when making a scratch. Question number one. Hitting distance. Given this shit ain't working. Right, we got a pen, guys. Oh no, the guy left. These are the given. Skidding distance. What does skidding mean? Bruh. Oh. 2.55 seconds. So this is time. Meters per second is speed. Because acceleration is meters per second squared. Skidding distance. Alright. Let's use. Trying to find distance. So we're trying to find. How do you do this? Oh yeah, I should have music. Another bot.
That's 5.
Freaking bot, dude. There's so many of them. Yes, I want to be popular. Like you.
You have 10 minutes to finish your research. You rush into searching on Google, then you find a title that sounds credible. You enter the page and start reading with all your attention.
Those right, it was
By the time you read through the
speed
entire
times
thing,
time,
you
yeah.
realize the content actually has nothing to do with the title.
Ah, damn, bro.
In this video, we're going to learn how to take the distance between any 2 points in our xy coordinate plane. And what you're going to see, it's really just an application of the Pythagorean theorem. So let's start with an example. Let's say I have the point, I'll do it in a darker color so we can see it on the graph paper. Let's say I have the point 3, comma, negative 4. So if I were to graph it, I'd go 1, 2, 3, and then I'd go down 4. 1, 2, 3, 4. Right there is 3, comma, negative 4. And let's say I also have the point 6, comma, 0. 6, comma, 0. So 1, 2, 3, 4, 5, 6. And then there's no movement in the y direction. We're just sitting on the x-axis. The y.
This is right. I don't even know. Wait, if you multiply two variables, does that mean they get subtracted? Is that how it works? Let's see. Choose. I'm gonna try using Opera. I wonder if Opera is actually faster. I don't even know, man. I've never used Opera. I'm gonna look if it's actually faster. Jesus Christ. Why is my computer dying? Maybe I need to adjust more stuff in OBS. Wait, how do you do that? I'm just gonna close this. The only thing I don't like about it is that my stuff in my Google account aren't there. Like the search history and the plugins. Mostly the plugins. How do you do that? Oh, this one? You know, if I get like 3 consistent viewers over like a period of days, I can actually start making money in Twitch, I think. Become a Twitch affiliate. And that will mean that I can't stream on other platforms at the same time anymore. Wow, this is sick. What am I looking at? Teach me Atam. Atam, teach me. What do I do? What am I looking at? Guess I just do this. Freaking 50% OBS. Why is it so big? Oh yeah, Twitch. Dude, 50% of my seat. Probably. My OBS has a thing that I can just read the chat. Still dying. The life of a poor streamer. I'm just a small streamer for fun. Hogs. Oh, Jesus. Oh, jeez. What is happening? This is even slower. Dying. Yeah, bye. Oh, maybe it's because I have two cameras. Okay, how about that? Is that better? Okay, now it's 40%.
I recreated every single set from Squid Game in real life. And what
Okay. Wait, fractions? No. Variables. Fractions J. Fraction.
When you divide fractions, you leave the top one alone. Write it down exactly like it was, and then you multiply it by the flip of the other fraction. So I had 4/5 to begin with. I'll have 5/4 at the end. And I could just multiply straight away. 2 times 5 is 10. 3 times 4 is 12. But this is not reduced because 2 will go into the top and the bottom. 2 will go into 10. Well, let's even write it. So 10, I can write that as 5 times 2. I can write 12 as 6 times 2. And when you see the same thing being multiplied on top by the same thing being multiplied on the bottom, you can simply cancel those things out. And again, if I reduce 10/12, I will be left with just 5/6 at the end. Okay? So dividing fractions, you're just going to flip and multiply. Notice also in this example, if I have 2/3 times 5/4, I could write 5/4 instead of 4. I can write that as 2 times 2. And again, basically, if I see something on top, I can cancel that out with the same thing on the bottom. So don't think like there's a 0 on top. Still think about there as being a times 1 on the left side. Well, 5 times 1 is 5. And then in the denominator, I'm left with 3 times 2, or 6. So let's do some more examples with just some numbers in here. Then we'll move on to variable expressions. Suppose I have 12 over, let's make it 25. And suppose then I have, let's make it 4 over 15. So if I want to divide these, again, I can just leave the top fraction alone, 12 over 25, and then I'll multiply that by the flip of the denominator, so 15 divided by 4. I could start multiplying straight across the top and the bottom, and then I would have to start reducing that fraction. So an easier thing to do typically is to factor it out at the very beginning. So notice I can write 12 as 4 times 3. I can write 25 as 5 times 5. I can write 15 as 3 times 5. And since there's a 4 on top, I could write 4 as 2 times 2, but since I see a 4 on top, I'm just going to leave it as 4. And okay, I see a 4 on top. I can cancel that out with the 4 in the bottom. I see a 3 on top, but I don't see any 3's in the bottom, so I can't do anything with that. However, I do see a 5 on top. I can cancel 1 5 out in the numerator with 1 5 in the denominator. I'm left with 3 times 3 on top, and I'm left with just a 5 in the denominator, and that'll be my answer. If you have more complicated expressions, suppose I have x over x plus 1 divided by, let's make it x squared minus 1 and 4x. So here's my big division sign. Again, the exact same idea. I'm going to leave the top one alone.
Huggers. It is still dying. Happy delivery. Happy big Christmas sale. You be dying. Man, why is it OBS take so much? It's at 50. Oh, OBS. I don't understand. I thought I optimized OBS. Laggy.
Hey everybody, this is Paul. Today I'm going to be showing you how to use the distance formula. So the distance formula tells us the distance between
감사합니다.
between 2
Seven.
points on an xy plane. So let's say that we have 2 points. Let's say the first point
Yo, I fixed it. Think it worked. Oh, everything is faster. Except for this, it's not doing. To be fair, it is faster.
My job is to make college easier because students have a lot on their plates. Like Harper, an econ major who piles on the pressure. Grammarly can help her stress less.
This term paper's gotta be great. It's a third of my grade.
Your idea
G'day and welcome to the Tech Math channel. What we're going to be having a look at in this video is we're going to be looking at calculations involving speed. These are ones where we would either be working at, say, how fast something was going in terms of, say, kilometres per hour or miles per hour, given time and distance, or maybe we're working at distance calculations or time calculations. So everything involving speed, how far and how fast and that sort of thing. Now I'm going to assume when we're doing this that you don't know very much, okay? So we're going to be going through these and I'll show you a few good little tricks. Now this is my really bad drawing of a car and I've drawn this on here for a reason. Not to show you my astounding art skills, which I know they are incredible. But what I'm actually looking at with this is the thing most people understand with speed. Straight away, we have got ourselves
You see, we edit a lot of videos every day, so we don't
time. This might be miles per hour or something like this. So I'm going to write our formula down here. Speed is equal to, and I'll rub that out. So when we do this, we're going to say distance over time. Look, I'm going to leave that car up there for the minute, just so you can all bask in my great artwork. But you see, this will be something like speed of a car, again, is equal to 24 kilometres per hour. Okay, so kilometres per hour. Okay, so hopefully you're good with these. And this per second, it's the same sort of. Just one thing, watch well and something as speed as this. Well, I'm going to show you a little way of being able to change this formula around, and this is not involving anything dividing by this or timesing by this and then moving that over there and moving this over here. I'm going to show you far faster a triangle, and we're going to be using that to the distance. This would be the speed time. Example, I'm over here in Australia, but speed, 60. How long would this take? So we would use this distance, which is, okay, hour. Okay, now the answer to that, if we were to do this, is 16.6. Now 16.6 what? You're going to see here that this and this cancel each other out, so we're left with hours. Okay, and it makes sense. Okay, this is a time measurement. We've got our measurement in hours. This is actually the distance. Okay, distance. I'll put my thumb over this here, my yellow pen, and I'll say that it equals speed. Okay. Of what about we were doing 100 30 to show you.
What? No. You need the right part.
My job is to make college easier because students
God
have
damn
a
it,
lot
Grammarly.
on their
I don't need you.
plates. Like Harper, an econ major who piles on the pressure. Grammarly can help her
To show you a little pitfall here. Now, first off, what you're going to notice is we can go this times this correct. No, we can't. And I'll tell you why. Because our biggest problem with this is our units are not the same here. We've got time measurements where they're in different units. Now we have to get these units the same before we start. So I'm going to change this into hours. So 30 minutes is how many hours? And you're going to see that it's half an hour which I'm going to write as 0.5 hours. Okay, so our speed is equal, not working at speed, what am I doing? Our distance is equal to speed times time. So speed, which is 100 kilometers per hour, and this is times 0.5 hours. Trying to squash in my work there. Okay, so with this, what are we going to do now? We're going to multiply these guys out together. So 0.5 times 100, and we're going to get an answer of 0.5 times 100 is 50. 50 watts. Well, you're going to see that our hours cancel each other out because this is dividing and this is timing at the time. So we're just going to end up with kilometers.
Wait, what?
Okay,
Why?
so our distance is 50 kilometers.
Variables are different.
with
I have problems.
kilometers. Okay, so our distance
Damn it.
at the time. So we're just going to end up with kilometers. Okay, so our distance is 50 kilometers.
Why do
So
they
hopefully
cancel
you're
each other
fairly
out?
good with these. Okay, so there's a couple of distance, time at the time, 50. Multiply these guys out together. So with this, what are we going to do now? We're going to multiply these guys out together. So 0.5 times 100, and we're going to get an answer of 0.5 times 100 is 50. 50 watts. Well, you're going to see that our hours cancel each other out because this is dividing and this is timing at the time. So we're just going to end up with kilometers. Okay, so our distance is 50 kilometers. So hopefully
I don't know. I'm just gonna answer with this. You know what? This equals log driven. Bruh. Thanks for the heart. Photo. Nice. Right, to the Formula for A for acceleration is. You don't know this one. But the formula for time, which is distance per speed. Yeah, and acceleration. What's up here? I don't have a WhatsApp. What is this? Delta V delta time. Acceleration is equal to the final velocity minus initial velocity per time. Okay. Monkeys. Now I want to make code this. Try coding. Yeah, I should turn off that notification. Oh god. Acceleration. Right. What the frick? Wait, no, this is wrong. Yeah. Hold on. Oh wait, I put the wrong values. That's why it's wrong. I flipped it, I think. I don't have the time yet. Fog. Time, distance, speed. I'm right. Okay. Double check. Wait, what? What is wrong? Please, let me...
seconds. So, although officially what they're giving you right here are speeds, because they're only giving you magnitude and no direction, you can assume change in velocity over time. So the acceleration, and once again, acceleration is a vector quantity. You want to know not only how much is velocity changing over time, you also care about the direction. It also makes sense because velocity itself is a vector quantity. It needs magnitude and direction. So the acceleration here, and we're just going to assume that we're going to the right, 0 miles per hour and 60 miles per hour to the right. So what is the? It's going to be 8 seconds when it stopped. So it took a total of 80 seconds. So this gives us 20 over here in the due east. So every second, it can increase in velocity by 20 miles per hour. So miles
Wait, this is
per
rounded.
hour. That's the same thing as mph. And then we also
Okay, so it's not by distance, it's by speed and time. So dumb. What is pull or something? What is pull? Oh well, I think this is the right one. Okay, that's number 2. 3. Always one. velocity. Height placement. Height a vector quantity? Probably. Okay, this is the stuff I don't really. Let me log in. Da, 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 da. is basically how I learn stuff. I just it's like trial and error. I just like if I don't understand something, I just ask.
So I've got my
YouTube
essay written, and I've
or
been working
someone
on it for
else,
about a week.
I started with like how to algebra. I searched how to algebra, and then I found like a review of algebra, and I watched it, and then I looked at like stuff I didn't understand, like transpose, quadratic formula.
So now I'm going to show you how I use
I
Grammarly.
just put in YouTube how to use quadratic formula and all the stuff. Lowest common denominator, DCF. I miss doing that, but it's kind of tiring. Yeah. It was interesting though.
Over some equations that you need to know to solve projectile motion problems. So let's review some basic kinematic equations. Whenever
Yeah.
an object is moving with constant speed, displacement is equal to velocity multiplied by time. Now, when an object is moving with
why is it so
constant
low?
acceleration, there are four equations you need to know. The final speed is equal to the initial speed plus the product of the acceleration and the time.
Why is it low?
There's also this equation. The square of the final speed is equal to the square of the initial speed plus 2 times the product of the acceleration and the displacement.
Final.
Displacement is equal to the average speed displacement of the initial speed plus 2 times the product of the acceleration and the time. There's also this equation. The square of the final speed is equal to the square of the initial speed plus 2
What's that
times the
for?
product of the acceleration and the displacement. Displacement is equal to the average speed, which the average speed is basically the sum of the initial speed and the final speed divided by 2 multiplied by the time. As you can see, the third equation that I listed here looks like the first equation for a constant speed. Okay, I did not want to do that. So I can rewrite this equation like this. V average times t, where V average is initial plus final divided by 2. Now there's another equation I need to know. D is equal to V initial t plus 1/2. D is equal to V initial t. Now there's another equation I need to know. D average is initial plus final divided by 2. V average times t, where V average is initial plus final divided by 2. Now there's another equation I need to know. D is equal to V initial t plus 1/2 AT squared. So make sure you know that equation too. So what exactly is D? You can use D as displacement or distance. Distance and displacement are the same if an object moves in one direction and doesn't change direction. If it changes direction, then displacement and distance is not the same. But technically, D is displacement. Displacement is basically the difference between the final position minus the initial position. Now you can use this t squared, where h represents the height of the cliff. And now you can use displacement in the x direction, or you can use it in the y direction. So just keep that in mind. Now there's 3 types of shapes for projectile motions that you need to be familiar with. Let's say if we have an object and it comes off a cliff horizontally and then eventually hits the ground. That's the first type of trajectory you're going to be dealing with. So what equations do we need for this situation? The first equation that's going to help you is this. H is equal to 1/2 AT squared, where H represents the height of the cliff, and T is the time it takes to hit the ground. This equation comes from this equation. D is equal to V initial T plus 1/2 AT squared. Now, when you're using these equations, you need to ask yourself, am I dealing with the X direction or the Y direction? You gotta separate X and Y for projectile motion problems. We're gonna apply this equation along the Y direction. So this is really dy is equal to Vy initial times T plus 1/2 AY times T squared. Dy, the displacement in the Y direction, is basically the height. So that's H. Vy at the top is always 0 because the object is moving horizontally. The initial speed of the ball is Vx, not Vy. And so we get this equation. So H is equal to 1/2 AT squared. AT squared, it's not Vy. And so we get this equation. So H is Vx, not Vy. And so we get this equation. So H is equal to 1/2 AT squared. Let me just redraw this picture. So make sure you know the first equation that we just mentioned. Now, in addition to knowing this equation,
Nanda. Kuitsura. I don't know.
this video is going to be an updated version to an earlier video that I created on projectile motion. But let's go over some basics. The first thing you need to know are the kinematic equations. At constant speed, d is equal to vt. Vt. Displacement is equal to velocity multiplied by the time. Now, under constant acceleration, displacement is equal to the average velocity multiplied by time. And the average velocity is basically the average of the initial and the final velocity. You add up the initial and the final and you divide it by 2, if the acceleration is constant. Now, you also have some other equations. V final is equal to V initial plus AT. So the final velocity is equal to the initial velocity plus the acceleration multiplied by the time. Also, the square of the final velocity is equal to the square of the initial velocity plus 2 times the product of the acceleration and the displacement. Distance and displacement are the same.
Just show me the graph.
Then it's going to go down. Gravitational acceleration is negative 9.8 meters per second squared.
Yes,
For
that
this
is
example,
gravity.
We're going to round it and we're going to use negative 10 just to keep things simple. So let's say at t equals 0, I'm going to put the time inside the ball. Let's say the horizontal velocity, Vx, we're going to say it's 7. And the vertical velocity, Vy, we're going to say it's 30.
This is so cool.
Now, 1 second later, what do you think the horizontal and the vertical velocity will be? What about 2 seconds later, and then 3 seconds later, and so forth? So 1 second later, I should probably put that in a different color. horizontal velocity will not change. It's going to remain 7. The vertical velocity will change. And how much will the vertical velocity change by? The vertical velocity changes by the gravitational acceleration. Acceleration tells you how much the velocity changes every second. Since the gravitational acceleration, which is the acceleration in the y direction, it changes about 10 every second, Vy is going to decrease by 10 every second. So 1 second later, it's going to be 20. 2 seconds later, Vx is going to be the same, but Vy is going to be 10. 3 seconds later, Vy is now 0. At the top, it's not going up anymore. You only have horizontal motion, but Vx is still 7. Then Vy becomes negative. But Vx will always remain 7. Because Vx is constant, the acceleration in the x direction is 0. A projectile, by definition, is only under the influence of gravity. So if you throw a pen, once you release it from your hand, it's a projectile. A flying bird is not a projectile. It's in the air, but it has the force generated by its wings acting on it, so it's not a projectile. Projectiles can only have gravity acting on it. Air resistance is ignored.
Okay.
So this is going to be 2, 3, 4 seconds later. Vy is going to be negative 10. 5 seconds later, negative 20. 6 seconds later, negative 30. Now here's a question for you. What is the vertical velocity and the speed 5 seconds later? The vertical velocity, Vy, is negative 20. The speed is positive 20. Speed is the absolute value of velocity. Velocity can be positive or negative. Speed is always positive. Speed is the magnitude of velocity. Speed is a scalar quantity, velocity is a vector. Vectors have magnitude and direction. Scalar quantities. Speed is a scalar quantity, velocity is a vector. Vectors have magnitude and direction. Scalar quantities only have magnitude only. Now if you notice, because the acceleration is negative, the velocity is always decreasing. On the left side, it goes from 30 to 0, so it's decreasing. On the right side, from 0 to negative 30, it's still decreasing. So the velocity is always decreasing. However, the speed, because it's never negative, it's positive on the left side and the right side. So notice that the speed is decreasing on the left side, but on the right side it's increasing because it goes from 0 to 30. So whenever the ball travels upward, the velocity decreases and the speed decreases. But as the ball begins to fall back down to the ground or towards the earth, the speed increases and the velocity continues to decrease. Make sure you understand that.
What?
Continues to decrease or towards the earth. The speed increases and the velocity continues to decrease. Make sure you understand that.
Okay, what?
Now there's 3 types of trajectories that you need to be familiar with. So here's the first one. Let's say if we have a ball that rolls off a cliff and it falls down. H represents the height of the cliff. R is the range, which is the horizontal distance between the base of the cliff, which is here, and where the ball lands. Now, because it's moving horizontally, initially, the initial speed is Vx and not V. Well, V and Vx are the same, but the initial speed is Vx. At the top, whenever it's moving horizontally, Vy is equal to 0, as in the case of the other problem. So you can easily find the height using this equation. H equals 1/2 AC squared. It comes from this equation. Now, because height is a vertical displacement, everything in this equation that we use has to be in the y direction. So we need to use dy, vertical displacement, Vy initial, times t plus 1/2 ay t squared. Now, dy is basically the height. At the top, Vy is 0, so this term disappears, and so you get this equation. So make sure you know this equation. H equals 1/2, or the maximum height of the trajectory. You'll be given the velocity v and the angle theta. So to find Vy is v sine theta, so just keep that in mind. Now to use the quadratic formula, make sure you have a 0 on one side of the equation. T,
What just happened?
to go from point A to point B, it's equal to v sine theta divided by g. And another is basically the height. At the top, Vy is 0, so this term disappears, and so you get this equation. So make sure you know this equation.
equal to the initial velocity times time plus 1/2 of AT. Acceleration multiplied by time squared. Why is it?
At the top, whenever it's moving horizontally, so you can eat this equation, the vertical displacement. Everything in this equation that we use has to be in a y direction. So we need to use dy, vertical displacement, vy initial, times t plus 1/2 ay t squared. Now, dy is basically the height. At the top, vy is 0, so this term disappears, and so you get this equation. So make sure you know this equation. h equals 1/2 at squared. It's very useful for this type of trajectory. Now, if you wish to calculate the range, it's equal to vxt. Remember, we said that whenever an object moves with constant speed, it's equal to v of trajectory. Make sure you know this equation. h equals 1/2 at squared. It's very useful for this type of trajectory. Now, if you wish to calculate the range, it's equal to vxt. Remember, we said that whenever an object moves with constant speed, d is equal to vt. Now, vx is v cosine theta, and vy is v sine theta. It's based on this triangle. Here's v, vx, and here's vy, and here's the angle theta. And here's vy. V cosine theta, and vy is v sine theta. It's based on this triangle. Here's v, vx, and here's vy, and here's the angle theta. Now, according to SOHCAHTOA, perhaps you've seen this if you've taken trig, S stands for sine. Sine theta is equal to O and H stands for opposite and hypotenuse. So sine theta is the ratio between the side that's opposite to theta, which is Vy, divided by the sine that's the hypotenuse, which is across the box, and that's V. Cosine theta is equal to the adjacent side, Vx, divided by the hypotenuse of V. Tangent theta is equal to the opposite side, which is Vy, divided by the adjacent side, Vx. So from this equation, if you multiply both sides by V, you can see that Vy is V sine theta. Now for the second equation, if you do the same thing, Vx is V sine theta. Now for the third equation, it's useful to calculate the angle. If tangent theta is Vy over Vx, then the angle theta is the inverse tangent of Vy divided.
Wait, I think I've learned about this. I have a Godot script for. Yeah, no viewers. It's okay though. I'm just studying. I'm sure I had one. Wrote that. Okay, this is the that was my my first success pricing check. It's like It is Steam. What about it? Oh great, that's the one. Wait, that was linear interpolation. What happened? Did I just quit it?
Divided by Vx. Now, according to the Pythagorean theorem, there's one more equation that we can write.
Wait, so Vy is height then? I love this. It's actually really fun. What is this again? Rational function. Then. Oh, denominator. Alright, I was trying to make a graph. You guys want something cool? No. You guys want to see something cool I built out? Where is it? Where is it? What? Where did it go? Oh, there it is. It's laggy. No, it's crashed. Why did it? Oh, the cool thing. Dude, it won't play. Laggy. Post this out. Let's just save this. I'm just gonna wait. It saves. Yeah, it'll be saved. Right. Let's pog. Still dying though. I made a spiral with code. Goes on forever. Very pog. Very proud of this work. Tingnan mo, Luisa. Oh, do you remember this? Goes on for. A spiral. Just showing them this. I don't know. Well, that's all. Why does it have no window? You know, I'm gonna go now. I have to do another one. Schoolwork for tomorrow. We're gonna have like a debate in Filipino and have to study for it. That was fun. I actually had fun.